Let's understand what an agentic RAG. Before that, first let's understand what RAG is, and then we will see the difference between RAG and agentic RAG with hands-on coding. Okay, we will be using a framework called LlamaIndex. Let me take you to the official page of LlamaIndex. Initially, LlamaIndex was used mainly to build RAG, that is Retrieval-Augmented Generation based applications, but now LlamaIndex has been evolved and it can be used for building AI agents as well. The building blocks of LlamaIndex are components, tools, agents, and workflows. And the advantages of using LlamaIndex are it has a clear workflow system and advanced document parsing with LlamaParse. Also, many ready-to-use components are available. Also, we have something called Llama Hub. Let me take you to the Llama Hub official page. Inside Llama Hub, we will be able to find different AI tools that are uploaded by various users. And Llama Hub is an open source system where we will be able to get different AI tools in one place. And this is one of the advantages of using LlamaIndex over small agents. Because of the number of agent tools that are provided by Llama Hub, you can see here our integrations include utilities such as data loaders, agent tools, Llama packs, and Llama datasets. We make it extremely easy to connect large language models to a large variety of knowledge and data sources. Use these utilities with a framework of your choice, such as LlamaIndex, LangChain, and more. We will learn how to use these tools in our hands-on project. Okay? So we will build an agentic RAG system in LlamaIndex. But first of all, let's understand what a RAG is. RAG is very useful for building chatbots, and also RAG is used to reduce LLMs hallucinations as well. So we need an input document, right? You can use any input document as per your project needs. Once you have it, go to resources and upload it there. I'm using this PDF as the input document. This PDF is about how organizations are rewiring to capture value. And this PDF has a lot of text, charts, and how GenAI is used in the organization. Also, this PDF was prepared by McKinsey, but you can use any document you want. So we have this PDF as our input document, and then we ask a question to LLM as, who is Bryce Hall? You can see if you search by doing Control F, Bryce Hall is mentioned 3 times within the PDF. First, let's understand what happens once we ask the question to the LLM. The LLM loads this entire PDF document into the LLM's context window, and then the LLM will try to answer. This approach works better when we have a few documents, but when we have several PDFs, for example, hundreds of PDFs, then loading all these documents into the context window can be problematic, right? Because we know each LLM has a limited context window size. As we feed more documents to the LLM, then the LLM may start losing the context and it can start hallucinating the results. Just like humans, we cannot retain a lot of information, right? And to resolve this issue, they introduced RAG, Retrieval-Augmented Generation. The concept of RAG is when we send a prompt or input sequence, that is, who is Bryce Hall, to the LLM. In our example, our PDF has 26 pages, right? So we convert the text on each page into higher dimensional vectors. Let's assume we convert each page into 300 dimensional vectors. So we have 300 dimensional vectors for each of these 26 pages. And what do we mean by converting into 300 dimensional vectors? We have a concept called word embedding. By using this, we can represent text into higher dimensional vectors. So each one in green contains compressed information of the entire text present on each page in red, starting from page 1, 2, 3, and so on till page 26. So each vector represents the meaning of the text present in each page. And how are they converted? We have some amazing techniques like word to vec. We can use these and meaning can be captured into vectors. Okay. So the intent of word embedding is capturing the text into a vector effectively. And then we will convert our prompt or the input sequence that we will be providing to the LLM into vectors as well. After that, we will see which one of these 26 vectors is closer to the prompt vector. Closer means either cosine similarity or Euclidean distance. By using this, we can identify if two vectors are similar to each other. That is, if the dot product is higher, then those two vectors are similar to each other. Once we find the dot product between the prompt and each one of the 26 vectors, Then we will retrieve the top 3 pages or documents that have the highest similarity with the prompt. Assume the yellow highlighted ones have the highest similarity with our prompt. Then instead of the entire PDF with 26 pages, we will only be passing the top 3 pages that have the highest similarity. In our example, it will be page 2, 3 and 26 along with our prompt to the LLM in order to retrieve the answer. So along with our prompt, we have passed only the information which is relevant to the prompt to the LLM, that is only the retrieved documents or pages, page 2, 3 and 26 to the LLM along with our prompt. That is, instead of passing the entire PDF with 26 pages, we passed only pages 2, 3 and 26. These are the retrieved documents that are very similar to our input sequence or prompt. Okay. So you can see the difference between these two scenarios, right? In the first case, everything has been passed to the LLM, whereas in the second case, only the relevant retrieved documents have been passed to the LLM. That's why they named it Retrieval-Augmented Generation, because we are taking the retrieved document, that is pages 2, 3 and 26, and then we are augmenting with our prompt and then generating the answer. That's why the name Retrieval-Augmented Generation, RAG. Sometimes we call this grounded generation as well, because we are passing the most relevant information, only the pages 2, 3 and 26. So the answer will be more grounded in reality, right? The biggest advantage of using RAG is that LLM's hallucinations can be reduced because we are passing the most relevant information to the LLM along with our input prompt. This is the whole concept of RAG, Retrieval Augmented Generation. Let me explain RAG in another way. Understanding these concepts are very important before we implement the hands-on project. Okay, so let's go to Wikipedia. We have a very good image over there. I found this very useful. This is our LLM and this is the prompt. Along with our prompt, we are passing these documents as well to the query. What are these documents? We take our original query and we convert it into vector embeddings. Also, we take our additional documents and we convert them into vector embeddings. And then we are doing a similarity search. That is, we are checking out of all the additional documents which are more aligned to our prompt vector, and that will give us the list of similar documents. And then we will augment with the query, which will give us the modified prompt. This modified prompt will be passed to the LLM and that will give us the most accurate answers. And the place where we store these vectors is called vector database. We have several techniques that can help us do the vector similarity searches. FAISS, Pinecone, ChromaDB, Viaviate, Milvus, etc. So we understood the concept of RAG. Overall, we have these steps. Step 1 is load documents. That is, we load the input documents. Step 2 is split documents into chunks. In our example, 26 pages is our input document. I have explained different text chunking methods with practical examples in my other course. You can refer to that if you're interested to deep dive on how chunking will be done. Okay. Step 3 is define the LLM embedding models. So we have LLM as well as an embedding model. Step 4 is create vector index. So we have the vector database to store the embeddings, and the vector index will help us to go through the database and identify the vectors which are similar to our prompt. Okay. Step 5 is create a query engine. Step 6 is ask query. We are retrieving the similar chunks from the input document, pages 2, 3 and 26, and then append retrieved chunks to the LLM prompt, and then we generate the final answer. These are the RAG steps, but you will understand better once we do the hands-on project. Okay.